Hi guys, how are you doing? Yeah, today we will learn about the inductor. You know what I mean? So we will, before start of inductor, we will quick review about the impedance R, X, Z. Okay. So guys, look at that. We learn about resistor, reactance, and impedance. What is the common part? Three of them, common part. The three of them common part is, I will say, it's prevent or interrupt the current flowing, right? Prevent. If the current is going, it cut, prevent like this. Cannot like this, right? And R is, I will say, rear use or rear loss, like heat, or actually, for example, I give you chocolate, I actually eat, it's gone. Or I lost it, it's gone. But X, reactances, I gave you, I store it, and I return back. So actually, I didn't use it, right? So I will say this is a reactance. And impedance is R plus JX, right? Yeah. So X and Z, I will say we will see it in AC. And just a resistor, we can say in the DC, right? Actually, yeah, we also could see it in other ways, but to understand easy, just impedance and reactances, you guys can see AC and R is DC, just for understanding easily. And this is the triangle, impedance triangle, Z, R, X, right? As you know, guys, here real number, here is image, J minus J plus minus, right? So R is here, real part, actual use, right? X is imaginary number here, J part, right? So we will say this is impedance, impedance degree, impedance degree. And this is a cosine, right? Cosine theta. So it gotta be power factor. Yeah, this is a quick review about what we learned from about what is impedance, R, X, Z, right? Let's move on, guys. So today we will learn about physical property of inductor. So first of all, inductor, we could say coil or reactor inductor, right? Actually, it doesn't matter, it's same meaning, okay? So specifically, we actually, classify the, specifically we classify them like separate them, how we call it. But we could say like inductor, coil, reactor. It doesn't matter. We could understand, right? So let's move on, guys. Yeah, look at the guys first. Inductor, I will say first of all, you guys need to remember inductor is inertia's element, inertia. You guys know inertia, right? So look at that. This is Lenz's law. It's really important. So V T dt minus d pi. What does that mean? Time goes by. If the flux is changing, the voltage is induced. And this minus means inertia. Yeah, it's really important. Have to memorize, okay? And yeah, for example, here, look at that. Inertia. What I meant inertia is, look at that. This is magnet, right? The magnet is coming to the, look at that. Okay. Coming to the coil, right? Here, coil, right? But because of inertia, make it, this way. So this picture is making this. Look at that. The coil, the magnet is, inside of the coil, right? But because of inertia, this part, you can see this part, this way. That's why this equation we have to memorize, okay? So I will define the inductor is, it suppresses the sudden change of current. You know what I mean? It prevents or suppress the sudden change of current. So what I meant is, look at that, guys. Okay. This is time. This is current. I will say ampere. For example, 10 ampere. Right? If the circuit is just R, if there is, so look at that. This is 10, 100, source voltage, and this is 10 resistor. So I is Ohm's law, V, right? So 10 ampere, right? So if there is just R in the circuit, if we switch it, the current is gonna be, look at that, from 0, right? But when I, close the switch, it's gonna be like this, right? But look at that. If this is L, you know what I mean? Inductor or coil, okay? So if there is coil, what happened? Look at that. This is really different. So if the coil is here, the current is gonna be like this. Why it happened? We will learn about this, okay? So first of all, you guys may memorize or remember this. I said flux pi n equal to current, right? For example, now, if I'm current, in the middle of the me is a magnetic field, flux, right? It's the same. It causes the flux and it also causes the current. Same, but only difference is the different dimension, okay? So yeah, you guys need to memorize this concept. That's why we could understand the Lance's law. Okay. So what I mean is, look at the guys. I said it happened, same time, right? Simultaneously. So what I mean is, look at that. Okay. For example, I said inertia is dt, where is Vt minus dt d pi, right? It could be I, right? Also. So time goes by, the flux is changing, V is induced. But today we will focus on this minus inertia. So look at that. Here's coil and come to here, flux. But because of inertia, we make it this way, right? But as you know, inertia is, not constant power, right? It suddenly happened and disappeared, right? Inertias. So look at that. 10 ampere here, right? Here is a minus 10 ampere. So when it closes the switch, look at that. Because of inertia, look at that. I put 10 ampere, but because of inertia, it happened. It make it minus 10 ampere. That's why. So 10, 10. That's why it starts 0 and slowly like that. But look at that. I said that the inductor is, it suppresses the sudden change of current, right? So that's why inertia is, disappeared like this. Here is 0 ampere. You know what I mean? So look at that. Because of inertia, plus here, and plus, like for example, minus a 10 is just 2, like this. And this is, what do I say? Like minus 1, and here is a 10, right? Plus this, so this is 9. So inertia is, not constant power. So it disappeared. But because of the inductor's property, it disappeared not suddenly, like kind of smoothly, you know what I mean? Not suddenly disappeared. That is, yeah, what we learned today. And look at that. For example, For example, here is the inductor, right? If, for example, I will make it two circuits, okay? So if it's 100 and 10,000, the magnitude here, what happened? What's the differences? So look at that. If it's this graph is 100, and the second graph, what happened? Like this, needed more time, more suppressed power. You know what I mean? More prevent the sudden change of current. That is, we say tau, R, L. So how, fast it disappeared, the inertia, we say. Yeah, today's, yeah, lecture is done. See you guys.